Okay, we are now here on note 7.4, indirect measurement. This is where we take what you've been working on this whole unit and apply it to some real life situations. So you might have seen some surveyors out doing things with like camera-like equipment, marking lines like this, or sometimes people just need to estimate the height of buildings or trees. And so this is what we use. It's called indirect measurement. And so the way indirect measurement works is we have two triangles here and we just set up our proportions. And so I'll use the smaller triangle is always going to go first. So my ratio of the smaller triangle is 10/5. And then I just make sure I match up. So the bottom of this larger triangle is the 22/x. And I have my proportion now. I can cross multiply to get 10x equals 110. And I divide by 10. And so that gives me x equals 11. And so I know the missing side of this triangle is 11. Alright, example 2, they actually have a picture for me. Here we're trying to estimate what's that height of the building without getting up and trying to actually measure using ladders or a really long rope or something. And so we're looking at the ray of the sun coming down, hitting the tree. We know the shadow of the tree is 24 meters long, the tree is 21 meters high, the shadow goes 56 meters, and so we're trying to estimate the height of the building. And again, I'm going to put the smaller triangle is going to be my first proportion, so I will do 24/21 equals my 56/x. And I make sure I matched up my two bases of the triangles and the two heights. And then I cross multiply. These are big numbers, so I will use the calculator to help me. That gives me 24x equals 1,176. I divide by 24 to get 49 meters as the estimated height of the building. Alright, our next example is even more fun because we get to draw our own picture. And so we're going to read, see what's going on. So Stephanie stands 2 feet from a lamppost. Okay, so we're going to have someone standing 2 feet from a lamppost. Her shadow is 3 feet long. If Stephanie is 5 feet tall, how tall is the lamppost? So when you hit these problems, remember we're always going to be making triangles because that's what this unit's about. And so I'm going to start by drawing a lamppost. And this is going to be one of those nice little old-fashioned lamps, and you can use your imagination if it doesn't look like that to you. So here's my lamppost. 2 feet away is Sophie. And I'll draw a little dress on her. Okay, so there's Sophie, smiling, very happy. That's 2 feet there. We know Sophie is 5 feet tall. And then she has a shadow going past her another 3 feet. And so the triangle would be the ray of light coming off the top of the lamppost down to the end of the 3 feet. And so we have Sophie's triangle. She's 5 feet tall, and her shadow is 3 feet long. We need to find out how tall the lamppost is. That's our x. And this is where we have to find out the total distance from the lamppost to the edge of the shadow would be our 3 plus 2, which equals 5. And so we have our proportions set up. Now we cross multiply to find out 25 equals 3x, divide by 3, and that gives us 8.3 feet. And we always check when we're doing word problems or real life problems, is that logical? Yes, an 8 foot tall lamppost is logical. If we'd gotten 20 feet tall or 2 feet tall, something was probably going wrong. So now flip over to your next page. We have 2 last examples. And so this is talking about Old Faithful in Yellowstone National Park. The ranger can estimate its height by comparing it to the height of a tree. First, the rangers locate a tree of the same height, and then they find the shadow of the tree is 93 feet. At the same time, the shadow of a 6-foot tall ranger is 4 feet. And so here, again, we're going to draw and try to make a triangle. And so I have a tree, very tall tree probably, and a shadow coming out this way that is 93 feet long. This drawing is not going to be completely to scale, but we'll try. And so then here's our ranger. He's also smiling, sort of. And he is 6 feet tall, and he has a 4-foot shadow. And we're trying to find the height of the tree. Alright, and this is again dealing with the shadow coming down over the top of the tree. That would be the sunlight. And so, again, we do our smaller triangle first, so I'll go 4 over 6 equals my 93, which is the shadow of the tree, over x. And I'm going to cross multiply and divide. And so that gives me 558. I'm going to double check my math there. So, I'm sorry, 4 times 93 is not 558. I thought that looked strange. So that gives me 372 equals 6x. I divide by 6, which gives me 62. Okay, and then I check, is this logical? 6 feet and a 4-foot shadow, and 62 feet and a 93-foot shadow. That's not a logical answer, because the tree has to be taller than the shadow, because the ranger is taller than his shadow at this time of day. So I'm going to come back and check. Did I put my words first like we talked about the first day? So that should have been his shadow and the height. And I see I mixed up my second ratio. That should have been 93 over x. And this is where you always want to double check things like that. Is your answer logical? Did you make those mistakes? So let's check it again. So I have 4 over 6, my shadow on top, 93 over x. Now when I cross multiply, I get 6 times 93, which is 558, equals 4x. I divide by 4 and get 139.5 feet. And I check that is a logical answer. That's a bigger number than 93. It looks about proportional. 4 over 6 equals 139.5 over 93. And so this is just to make sure you double check those things, especially when we're on the word problems. Alright, and our last one. This one says we have a mirror on the ground 8 feet from Ricky and 19 feet from a flagpole. And so what we have to recognize doing this is the mirror is on the ground here. And we have Ricky 8 feet to one side. There's Ricky, always happy because it's math time. And then 19 feet this direction we have a flagpole with an approximation of the Texas flag on it. Alright, and so we know this is 19 feet, we know this is 8 feet, and Ricky is nice and tall. He is 6 feet tall. We're trying to figure out how tall the flagpole is. And so the reason they tell us this is the mirror is he can see the top of the flagpole, which means his line of sight is going down to the mirror, bouncing up to the flagpole, top of the flagpole. That's what makes our triangles for us to deal with. And so even if you weren't able to draw that whole drawing, you could probably recognize the 6 over 8 and the x over 19. And so I'll draw my proportion, my smaller triangle first, and I make sure I'm doing the ground level together. and then the height. So Ricky is 6 feet tall. We are trying to find the height of the flagpole. We know that the ground part we can measure is 19 feet. And now we cross multiply. 6 times 19 is 114 equals 8x. Divide by 8. To find the flagpole is 14.25 feet. And we check, is that logical? Yes, it's a little, 6 over 8 was a little shorter. 14.25 over 19, it's a little bit shorter. That's a logical answer. We are done with our examples.